Hi, everybody. This is Unit 5, Topic 5 for Calc AB. And the notes in your packet should begin about page 18. And the title for today is Using the Candidates Test to Determine Absolute Extrema or Global Extrema. And so the essential question is, how do I use the Candidates Test? So when we talk about absolute extrema, we're talking about the biggest of the big and the littlest of the little. And there's a nice process here that's really streamlined and goes very quickly. So if you remember back to earlier in the unit, we had the extreme value theorem that said a function that is continuous in a closed interval must assume a global or an absolute maximum and a global or an absolute minimum over that interval. So we have to have a biggest of the big and a smallest of the small. And those extreme values can only occur at the endpoints or on the interior at critical points. Remember, critical points are a common theme in this unit. We find them in just about every problem. So when we set the derivative equal to 0, and then we also look at the derivative and see if it can be undefined, if it's rational, and we have any undefined x locations as well. So we have kind of an extreme value theorem for as it relates to the candidates test. And that kind of goes, since there must be a maximum and a minimum value on the closed interval where the function is continuous, to find those values, we need only search at these locations where they occur. And so the only locations that they can possibly occur are at critical points and endpoints. And so the critical points and the endpoints become known as the candidates. It's the x values that we're evaluating. So kind of the takeaway here, we're talking about extreme values. We know we need a continuous function. We know we need a closed interval. And then we need to know we need to evaluate the endpoints and the critical points, and we call those candidates. So the candidates test applies to a continuous function, because it is a offshoot of the extreme value theorem. And so the idea then is the first thing we need to do is locate critical points inside that interval. And again, this is a reoccurring theme in this unit. We're doing this almost every day, where we're getting the derivative, setting it equal to 0, and then seeing if it's undefined. And then we list the critical points and the endpoints in a table, and that's called the candidates table, and the critical points and the endpoints are the candidates. And then we evaluate the function at all of those points. And then it just simply requires us to say, hey, if I want the absolute maximum, I'm going to pick the biggest value. Or if I want the absolute minimum, I'm going to pick the littlest value. So let's take a look at where a table is not possible. And that's this problem. It says f of x is a continuous function, so we need to have that criteria met. And we're going to look over the interval -3 to 5. And over that interval, all they're going to do is tell us about the sign of the derivative, so that we don't have any functions to use any algebra on. So they say that the left-hand side of the interval from -3 to +2, the derivative is positive. And then on the next interval from 2 to 5, the derivative is negative. And that's all we know. So we know enough to kind of sketch it out. So from -3 to +2, the derivative is positive. That means f is increasing. So I'm just going to draw a generic curve where f increases, which means the slope of these tangent lines, anywhere we draw them, are going to be positive. And that means the derivative is positive. And then from 2 to 5, I'm going to draw something that is always decreasing. So it looks like that. So because of these descriptors, we can only get some sort of curve that looks like this. Where these lower points are, I'm not sure. Maybe this lower point's way down here. But it doesn't matter, because the question is what extrema is found on the interior of the domain. So the endpoints in this case don't matter. We just know we know we have a point at which the derivative is 0 here at 2. And how do we describe that characteristic of the function? And we would call that an absolute maximum. So we know we have an absolute maximum on the interval on the inside, right, the interior, from -3 to 5 with the round brackets. Or we could say there's an absolute maximum at x equals 2, because the derivative switches signs from positive to negative. You could also approach it and justify it that way as well. Okay, let's look at question 2, where we do have a function. And so we have f of x, it's x cubed minus 3x squared plus 12. These questions are typically no calculator, because if we had a calculator, we could just graph the function and talk about its extrema that way. So we're going to have to use the algebraic approach. We have a closed interval from -2 to 4. So this is what's the absolute maximum? What value does it occur, and justify our answer? So 3 parts to answering this question. Okay, so first we're going to find the derivative. It looks like it's 3x squared minus 6x. We're going to set that equal to 0. We're going to go ahead and factor that, and we're going to set each one of the factors equal to 0 and solve those expressions. So we know we have critical points at x equals 0 and x equals 2. And then because this is polynomial, we know that we will not have cusps and corners. So, and we do not have a derivative that is rational. So we know that we don't have any locations where the derivative fails to exist. So these are only 2 critical points on the domain. Both of these points are inside the domain, so we have to include both of them. If we had critical points at x equals 0, x equals 2, and x equals 6, we would have to eliminate the x equals 6 because it would be outside the domain. So we can go ahead and set up our candidates table. -2 and +4 are our endpoints. 0 and 2 are our critical points. And then now we're left to just finding the function value at each one of those locations. So when I plug in 2, I get -8 minus 4 times 3 is 12, right? This is an even power. So -8 minus 12 plus 12, that's -8. So we know we have -8 at -2, function value. We'll plug in 0 here, we get 12. So we have 12 when x equals 0. At x equals 2, we're going to have 8 minus 12 plus 12. So it's going to be 8. So we have a function value of 8 there. And at 4, the other endpoint, we're going to have 64 minus 48 plus 12. So 64 minus 48 is 16. 16 and 12 is 28. So we know it's 28. So now we have all our function values, and now we can answer the question. We have all the criteria that we need. We have an absolute maximum, so there's the absolute maximum is 28. So f of 4 equals 28 is the absolute or global, whatever vocabulary word you want to use, maximum by the candidate's test, and occurs at x equals 4, occurs right here, because 28 is the largest value in the candidates table. That's literally the justification. Okay, let's take a look at question 3. So same type of question. And we have this function here. So we're going to start out by differentiating this. So we're going to push the 3 out and do the power rule on x to the 2/3. So I'm going to bring the 2/3 down, x to the minus 1/3, and then differentiate the next term, that's minus 1. I'm going to clean this up a little bit. This looks like 2x to the minus 1/3. And so x to the minus 1/3 is really x to the positive third in the denominator. So I'm going to write it like that because it's looking like this derivative is going to end up being rational. So I might have some undefined locations. And it's easier to see if I have that scenario, if I make this just one rational expression. So x to the 1/3 over x to the 1/3 is the way I'm going to write 1. So I'm going to have 2 minus x to the 1/3 on the top over x to the 1/3 on the bottom. And it's really handy to express the derivative as one rational expression instead of a rational expression and then an integer. Instead of 2 terms, I have 1 term. And that the reason being is because then if the numerator is 0, then the derivative is 0. And if the denominator is 0, then the derivative is undefined. So it's kind of like factoring where you have to set each equal to 0. I'm going to set the numerator equal to 0. And that's going to find my hills and valleys. And that's at x equals 8. And then I'm going to set the denominator equals 0 because that's when my derivative doesn't exist. And that's at x equals 0. So it looks like I have 2 critical points on the interior. One's at 0 and one's at 8. And then I have these 2 endpoints. So I'm going to go ahead and make my table. and then I'm going to find all those function values. So, and we've got to work with this fractional power. And when you have a fractional power, usually College Board gives you really nice values to work with. Like we have a cubed root here, right? That's the 3 in the denominator for the power. So they better give us perfect cubes to cube root. So let's see what they did here. They had -8 for x. So it's 3 times -8 to the 2/3. So let's break this down. If x is -8, it's negative. I'm looking at the 3 here, and I'm thinking the cubed root of -8 is 2, right? Is -2. -2 times -2 times -2 is -8. So -2 squared is 4. 4 times 3 is 12. That's how I got the 12. Minus -8. So I have 12 minus -8, that's 20. If you're having a hard time processing these fractional powers, let me know in class, and I can go through that with you in class. Okay, putting 0 in just gets us 0. So we know that the function value is 0 at x equals 0. Plugging in 8, let's go through that power again. So 8, so I'm looking at the 3 again. The cubed root of 8 is 2. 2 squared is 4. 4 times 3 is 12. So we have 12 minus 8, which is 4. And then let's do that one more time. Put 27 in here for x. So looking at the 3 again, the cubed root of 27, what times what times what is 27? So the cubed root of 27 is 3. 3 squared is 9. 9 times 3 is 27, and then minus 27, and that is 0. So I've got all my function values in my candidates table. I've got my endpoints and my critical points. So now I can answer the question. And the question is, what is the absolute maximum value? And the absolute maximum value over this domain is 20. So we're going to go ahead and wrap up our answer. F of -8 equals 20 is the absolute maximum by the candidate's test and occurs at x equals -8 because 20 is the largest value in the candidates table. So that's answering what is the absolute maximum. It's answering that what value of x does it occur, and I'm justifying it. So that would be the complete answer. Okay, so when we get into the classroom, we'll go over the takeaways and address your questions.